Algae as pollution indicator. Algae, as well as many other living organisms, are used to indicate the level of stress in the environment. There are also various physiochemical parameters to determine the level of pollution. But these physiochemical parameters determine the level of pollution based on the presence or absence of the physical or chemical parameters. But biological parameters, it determines the extent of the environmental stress at organism level, population level, and community level. So, for long-term management of the ecosystem and monitoring of the ecosystem, algal parameter or any other biological parameter is a better indicator of the community or ecosystem health. Hello friends, I am Ayantika, and in this video I am going to discuss about algae as a pollution indicator. What are the characteristics that makes algae an ideal biological parameters? What are the procedures involved in this entire process, and what are the algae in different polluted, unpolluted or other stressful condition? And also I will give you a very brief review of other pollution indicators. Now, among algae, not all algae are good as a biological indicator. Algae is mostly used for determining the water quality. But among the algae, microalgae are better preferred because of the small size, it is easy to sample and do the latter processing. Also, algae being of wide distribution both spatially temporally is a very good suitable model organism for determining the aquatic pollution. Also, it is available throughout the year. And also microalgae or any other algae, they accumulate pollutant. They cannot move away from the source of pollution. They are fixed, so they have to face the pollutant, accumulate it, or become resistant to the pollutants. These pollutants in turn affect their metabolic processes, and in turn this alteration of metabolic process is also causes the alteration in the life cycle. I mean the alternation in the growth rate, alternation in the cell division. So certain species they become very limited in their growth, and certain species they which are very resistant to the pollutant, they continue their normal growth. This causes a shift in the population dynamics in the community structure. Also, algae, due to the short life cycle, it easily determines a sudden change in chemical parameters, and also when the chemical stressful parameters is removed, these algal population also very quickly recover from the stress. Among the macroalgae is sampled because we can obtain the sampling at population or community level. Different, say for example, if we get a biofilm from a periphyton, that will contain community level algal populations of different algal species. Also, it is very much in use in the developed countries since many years, and the green algae like Chlamydomonas, Chlorella, Synestesmos and Selenostrum and many cyanobacteria are generally used for the bioassay. There are also limitations of algae as a bioindicator because the algae, it being the very first level or in a food pyramid, it being the primary producer. So the extent of pollutant, the extent of damage of the pollutant will be different in the primary producer as and the other higher trophic level. As we go higher up on the trophic level, there will be biomagnification. So the effect of stress will be increased manifold. And also different algae have different habitat requirement. So uh, if there is a stress, some algae will be very tolerant to the stress and some will die out. So we have to be very specific. We have to have get the knowledge beforehand that what type of algae will be specifically present in polluted water and what type of algae will be present in inorganic polluted water or organically polluted water. What type of algae won't be present in the polluted water. What type of algae will be present in very unpolluted clean water. So we have to get these knowledge beforehand before we start using algae as a bioindicator. Now, as we know, according to the level of nutrient or pollutant, whatever we say, any water body is divided into many categories. Oligotrophic, which is very nutrient poor and it contains very negligible amount of living organism. So this oligotrophic water body, it is attributed the color blue. Mesotropic water body, it is poor in nutrient but it has moderate plankton level and is assigned light blue color. The eutrophic, that is highly nutritious water body which has high growth of both algae and green algae as well as cyanobacteria, is assigned green level. And in eutrophic water, we generally see cyanobloom, algal blooms. Polytrophic is given yellow color. It has a very high planktonic growth and this high planktonic growth is due to the very high extent of allochthonous input. And usually the visibility is very low and it is assigned a yellow color. For collection of sample, that is algal sample, we use different techniques. Like, for example, in water where the water depth is high, we can use this type of net. Or if there is a very shallow water, then we can use this type of scrubber. Also, we can sample the algae on site using this aquascope. Algal samples should be collected. It can also be collected from the benthic algal samples can be collected from the pebble as it grows as a biofilm of various algal community as well as other microbial community on the surface of this periphyton. Periphytons are actually the algal and bacterial and mixed community that grows as a thin layer, as a film on the surface of pebbles that are on the sunny surface of the pebble. So we can also, if you want to collect benthic algae, we can collect it from periphyton. If you want to collect the planktonic algae, we can use this nets. On on-site algal sampling and analysis can be done using this aquascope. Now, if while collecting the benthic periphytonic samples, we can use either best tool is for a toothbrush, or we can just scrape it with a knife or a spoon. After algal collection, these algae can be preserved in uh, alcohol, Lugol's solution. But while collecting the algae, we should also have some rules, like it should not be collected from very near the bank. It should be collected at least 1 meter away from the bank, and the water should also not be very lentic or slow flowing. The water should be collected from a fast flowing area, and water should not have a depth. If we are collecting benthic algae, it should not have a depth more than 1 meter, and then the sampling should be done from a place which is exposed to sunlight. Shady portion from the shady portion of the river or the stream, we should not be collecting algal samples. Now, for after collecting of the algal samples and preparation, and after collection of the algal samples, we should analyze it either by just the species regions of the algae, or about their metabolic, how the stress is affecting the metabolism of algae. For determining the species composition, we can either study it in slides or special chamber, or a very cost effective and less time consuming is by using a particle counter or a flow cytometer, which is a very fast process. By while studying algal species in a special chamber or on slide, we have to first oxidize the materials. This oxidation is needed so that all the other colored material is removed, and only algal species can be observed very distinctly. So the algal species is taken and it is oxidized. The algal water species is taken and it is first centrifuged. After centrifugation, the bottom sediment is taken by decantation, and the bottom sediment is oxidized in hot water and then bleached. After bleaching, it is acidified, after which it is again water added to it, and the algal solution with water is again centrifuged and decanted as before, and the sediment is mounted on a permanent slide. We can also we can also find out the effect of metabolic effect of the various stress factor by determining the amount of chlorophyll, ash free dry weight, and other things. While determining the chlorophyll A content, which is common in all type of algae, it is actually a measure of the autotrophic index, means the rate of photosynthesis is determined by this process. The more an algae is under stress, lesser will be the level of photosynthesis, and lesser will be the level of chlorophyll. Also, under stress, certain algae have certain enzymes like catalase, peroxidase, glutathione reductase. If presence of these type of enzymes will determine stress. Also, certain enzymes like esterase, nitrate reductase, alkaline and acidic phosphatase, their content is altered during the stress. So by determining by the enzyme assay of these enzymes, we can also determine the level of stress in the aquatic environment. Ash-free dry mass. Ash-free dry mass is a mass of algae, and by determining the ash-free dry mass of an algae growing in very normal environment and the stressful environment, we can determine the level of stress. For determining this ash-free dry mass, we have to take the algal mass and dry it and then burn it in a muffle furnace. After that, it is taken out of the muffle furnace in a desiccator. After placing desiccator for a certain amount of time, this ashen mass of algae is taken out and weighed. So ash-free dry mass is a measure of how much the metabolic process of the algae is affected by the stressed condition. Also, the level of stress can be determined by the level of DNA lesion by using molecular techniques. Also, we can also collect the we can also get a relative amount of the number of living and dead cell by using dyes like dihydroethidine. This dye actually penetrates the plasma membrane of only dead cell and bind to its DNA. So, by using this dye, we can find out the number of dead cells and the living cells as they are not stained. So, we can easily differentiate between the number of living and dead cells and accordingly determine the level of stress. After determination of the algal species level, population level or community level analysis, we can put them in certain ecological modeling. Ecological modeling can be of first order and second order. First order is individual based, means it will find out the cell density of a particular species, ash free dry mass or the chlorophyll content or enzymatic activity of a single species. But while determining the community level, population level analysis, we can use the secondary order indexes. Palmer index, saprobic index, halobic index, species deficient method and Shannon diversity index are the most popularly used indexes for determining secondary pollutants, mostly organic pollutants. Palmer and saprobic, it determines organic pollution, and halobic, it determines the level of salinity. Palmer index has been used globally, and also in India it is used in several places. In Palmer index, Palmer 1969, he have given each algae a particular number, and he has categorized algae present in unpolluted water and algae present in polluted water. Saprobic index, it determines the Palmer index, it determines the planktonic diversity, how it is affected, and saprobic index on the other hand, it determines the zoo as well as phytobenthic population, how it is affected by the pollution. So Palmer and saprobic both are used. Palmer is for phytoplanktons and saprobic index is for the benthic population. Palmer index has been used by the Bureau of Indian Standards as it is very rapid and reliable. The saprobic index has divided the benthic flora and fauna based into four categories based upon the level of pollution. Halobic index also has categorized water body into fresh and saline, which are further subdivided, and this subdivision have different type of algae. This is the Palmer index. As we know that every aquatic species of algae has been categorized either into polluted and unpolluted. In polluted also it is divided into organic, inorganic, and by determining the algal species of a sampling area, we can easily find out the pollution index. Say for example, chlorella. For example, chlorella has an index number of 1, and we have all other species which have either 1, 2 or 3 type of index number. So after summation of all the index number, we can determine the pollution index at any site, based on which 0 to 10 pollution index has no organic pollution, 11 to 15 has very moderate amount of pollution, 16 to 20 have organic pollution but probably not very specifically, but 20 and more of the pollution index algae will determine that this water body has confirmed organic pollution. Saprobic index, it has quantified the benthic population into 4 groups. Oligosaprobic, it is present in less polluted water, and the moderately or heavily polluted is mesosaprobic, and grossly polluted water is polysaprobic. These are the chemical parameters associated with each level of polluted water. Saprobic index has classified the unpolluted very clean water as catharopic zone, which includes the following algal species. Oligosaprobic region and that has very less amount of pollution is further subdivided into xenosaprobic pollution, and these are the algae that are associated with xenosaprobic. Then mesosaprobic is divided into alpha, beta, gamma and delta saprobic. So mesosaprobic has mild to high amount of pollutants. This mesosaprobic alpha is highly contaminated, beta is mildly contaminated, and these are the associated algal species. You can pause the slide and read the names of the algal species. In polysaprobic, that is highly polluted zone, we do not find any algae except cyanobacteria. And polysaprobic is again also divided into alpha, beta, gamma, coprozoic, eusaprobic and transsaprobic. This alpha, beta and gamma were originally used, and eusaprobic and transsaprobic were later added. You can pause the slide and read the name of algae and bacteria present in each category. Halobic index, fresh water we see is divided into subdivided into infrahalobic and oligohalobic, each of which is again subdivided. The saline water body is divided into mesohalobic and polyhalobic, which is again further subdivided. You can pause the slide and read about the characteristic of the water associated with each category. These are the name of cyanobacteria that are present in a cyanoclone. These are algal species that are present in algal bloom. PERIPHYTON. While determining the saprobic index, we have talked about benthic flora. In benthic flora, actually any submerged water body will get a coating of organisms that might include algae, cyanobacteria, other type of bacteria, and also invertebrate animals also. This any submerged object with a film of organic film on it is periphyton. For determining the saprobic index, we take out the periphyton from a high flowing region of the river, high water flowing region of the river, and we take out the layer with the help of toothbrush or knife, and we analyze the periphytonic species. These are the algae present in polluted water. We also have some diatoms. Organic pollution containing water have this type of diatoms, and also green algae. The marine degradation includes the following variety of algae, and potential toxic elements also have this following variety of algae. Clean water algae are in the list. Now, heavy pollution has Stegioclonium tenuis. Middle level pollution has this algal species. You can pause the slide and read the name of various algal species present in various type of water, polluted or unpolluted water. Now, other organisms that determine the level of pollutions in fresh water or marine water are platypus, mussel, Grunion fish, red side dace fish, mayflies, lobster, Panulinus, it is a type of lobster, various type of trout, frog, the bacteria, uh, Wolfia globosa, other type of animal cues, zooplanktons, and aquatic invertebrates. All these are determinant of the level of stress in water bodies. Apart from the water pollution, canary bird, certain type of moss, lichens and bryophyte, they determine the level of air pollution. With this, I come to the end of my discussion. Thanks for watching. If you like it, please like, share and subscribe the video. Share it with your friends. These are the Facebook and Instagram links. Thank you.